Hello, this is Professor Stephen Neshaba, and I'm here to help you out with some of these computational exercises that have to do with simulating a titration curve. So here's kind of the general picture that we got. We have a titrant, sodium hydroxide, dropping into an analyte, some acid, weak acid HA, and the idea is that we're going to construct a pH titration curve, that is the pH of this solution as we drop in the strong base. And the information that we have from this is we know how many moles or millimoles of the unknown of this acid, HA. We know what volume it's in downstairs there in the analyte solution. We know the acid dissociation constant of the acid, and we know the concentration of the sodium hydroxide titrant. So I'm going to jump over here to Excel now, and if you want, maybe you could set up your situation, your Excel sheet, kind of like this. Of course, I've set up my own values that I'm going to use for demo, and you would put in your values here for the initial conditions. Okay, assuming you're back. Here, in my particular case, I'm saying that I've got 3 millimoles of the HA in the analyte solution, and it's in 25 mils. That's the analyte solution volume. Ka for my weak acid is 1 times 10 to the minus fifth, and the concentration of the titrant is 0.1 molar. And let's see, I guess I've already typed in the first number that I need here, which is that the concentration of the analyte is B1 divided by B2. That means it's the number of moles in the analyte solution divided by the number of number of millimoles divided by milliliters, which will give me the concentration of the analyte in moles per liter. So that's good. Now let's see, I need to go ahead and type in some initial concentrations. I've got my ICE table up here, so I'm going to say that my initial concentration of HA, of course, is that value right there, and I'm not going to have any A minus and no H plus. And you've already done this before, so if you want, go ahead and type in the next few values. Okay, I'm going to go ahead and do that now. Let's see, as the acid dissociates, that's going to change by minus X value. Okay, that looks good. And of course, I'm going to pick up some X. Let's see, equals the X value, and I'm going to say that's also equal the X value. So those are the change variables. I think that looks pretty good. And now the equilibrium, of course, is the sum of those. I'm going to introduce a new formula for the sum. It's sum, S-U-M, of those two guys right there. All right, so that's that, and then I pull that across. And let's see, I could go ahead and fill in this formula for the pH, but I think I'll wait on that. I think my next task is to get the QA to match my my acid dissociation constant, which is 1 times 10 to the minus 5. If you want, go ahead and do that in goal seek. All right, let's see if I can make that work. I need to say this quantity is equal to the products, which is that A minus times the H plus divided by the HA concentration at equilibrium, okay, which is of course 0 at this point. And now I'm going to go off to goal seek, and let's see, I want to set E7 to my known value, which is 1E minus 5, by changing cell X, and let's see if that works. And well, I think it worked out okay. And so that means I'm ready to calculate a pH value. If you want to go ahead and do that. All right, I think my pH will be minus the log of the H plus concentration, which will be that quantity. And now return. So looks like our pH of our solution is 2.96, and that will be the first point to put on our graph. And I'm going to go back to that graph. 2.96, that's 7, and so I would start with a point 2.96. Right there is our starting pH.